What's up guys, welcome back to the channel. Today on this video we'll be doing the standard trigonometric indefinite integrals. So guys, if you are new on this channel, I would like to welcome you to the channel, and also I would advise you guys to subscribe to the channel. Do not forget to click the notification bell there when you subscribe, so that it can notify you whenever I upload a new video. Just in case guys you're wondering, I am going to upload more videos on mathematics, and also I've already made the tons and tons of videos. You can go to the playlist section of this channel and watch the videos that you like to learn about on the topic that I've already done videos on. Alright guys, so let's talk about the standard trigonometric integrals. What you should know is that you need to know the derivatives of the trigonometric ratios. That's the thing. So if you don't know the trigonometric ratios, the derivative of trigonometric ratios, it's gonna be challenging for you guys to know the integrals of those trigonometric ratios. So on this side here, let me just separate these two. I'm gonna have two here. On this side here, I'm gonna do the derivative of the trigonometric ratios, and this side I'm gonna do the integral, so that you can see the difference between the two. All right, I hope you guys are ready for this, so let's do it. This might take long, so brace yourself. All right, so we have y is equaling to sine and then n x. Remember, n is the coefficient of x, and then the derivative of this trigonometric ratio is gonna give you dy over dx, which is gonna give you positive cos. It's gonna give you almost forgot the n there. It's gonna give you n positive cos n x. Now what about the other trigonometric ratio, which is our cos n x? What is our dy over dx of this trigonometric ratio here? It's gonna give you negative, unfortunately, or fortunately, in fact, negative n sine then n x. Right. What about our tan? So if we have tan, okay, and then we have nx there, dy over dx of tan, it's gonna give you n then sec squared n x. Right, these are the three trigonometric ratios so far. So what about their inverses? So let's start with the cosec. If we have cosec, right, I have cosec n x. What about its what about its dy over dx of cosec? So the dy over dx of cosec, it's gonna give you negative, or it's gonna give you dy over dx. It's gonna give you negative n cosec x and x multiplied by cot n x. I hope the space is enough. What about the one of the inverse of cos, which is gonna be sec n x? What is the dy over dx? So it's gonna be sec, it's gonna be in fact n, then sec n x. All right, what is happening here? N x multiplied by tan n x. There we go. And then last but not least, our cot. What about cot? Cot n x, the dy over dx of cot n x is going to give you negative cos n cosec squared n x. Guys, these are the derivative of the trigonometric functions. As you can see, this side, these are the trigonometric functions, and on the other side, these are the derivative of these trigonometric functions. Now, you need to know this, guys, in order for you to know the integrals of the following. For example, now this side here, let's do the integrals. Now, if we do the integrals, let's look at the first one here. If you have the integral of, for example, sine, positive sine n x, right? Remember, n stands for the coefficient of x. So the integral is going to be negative cos n x divided by n. I hope this won't affect the audio, right? Because now it's starting to be slow. So that is gonna be for sine, right? What about the integral of cos n x? All right. So what about its integral? It's gonna be, funny enough, this one's gonna be positive. So it's gonna be positive sine n x over n plus c. All right. So what about the one we don't have for tan for now? So we're gonna use one for sec squared and x, and then the integral of this is gonna be y is equal to tan n x over n plus c. All right. And then what about for cosec squared n x? The integral here is going to be y is equal to negative. It's going to be negative cot nx over over n plus c. Last but not least, what about this ones here, where we have 1 2 3 4? In fact, this is not the last one, but I'm running out of space. What about when you have sec, just create more space, guys. What about when you have sec and x multiplied by tan and x? Our integral here is going to be y is equal to sec n x over n plus c. Last but not least, I hope the space is enough here. When we have cosec n x multiplied by cot n x, the integral here is going to be y is equal to negative cosec. All right, negative, let me just create more space, a little bit of space here. Okay, negative cosec n x divided by plus c. Guys, as you can see, it's just the reverse of this. Remember, when we integrate, we are reversing from differentiation. So if you can look at this here, this side here, we are deriving here this side, and this side we are integrating. So these ones we call derivatives. What is it? Derivatives. Okay, and in this side we call them integrals. Integrals, there we go. So guys, I hope you are able to see how to do this one here. Guys, stick around so that we can able to apply these formulas. If you find this video useful, do not forget to like and comment, and also you can share this video to your friends. And do not forget to subscribe to the channel if you haven't subscribed. So I'm gonna make another video where we apply all these formulas here. As you can see, there are plenty, but we're gonna apply these ones because we are integrating. But you need to know this in order for you to apply this. Thank you very much guys for watching. At the end of this video there will be a playlist that will show this where we apply the videos where we apply these integrals here. So if you want to see how we apply them, I think you should click on that playlist. Thank you very much guys for watching. Till next time, cheers.